All right, so in this particular lesson, just for the sake of time and trying to get the concept down, we're going to use Desmos to get through this unit. So this will be a lot less labor intensive than you normally would have. We had to plug in a bunch of points, do a lot of graphing and figuring. I'm going to use Desmos to do all of this, so hopefully it'll go by a lot faster, a lot quicker, and make a lot more sense to you. All right, so we're talking about linear inequalities. You did linear inequalities already with one variable where you had either an x or a y or a z or whatever, but you only had one letter. Now we're going to be doing linear inequalities with two letters, and then we're going to do some real-world examples with that. So the first thing we're going to do is let's talk about linear inequalities in two variables. So here you're used to graphing y equals negative 2x plus 9, and we know how to do that. We go to the y-intercept, which is the 9, and then we move the slope negative 2 over 1 and make the line. But here we're looking at an area or region instead of just a line. Because of this, y is greater than or equal to, or there's an inequality symbol here. Remember that when you did number lines, you had, when you're putting on the number line, you had an open dot versus a closed dot, and you either graph to the left or graph to the right, that kind of idea. This is the same idea, except we have two variables. So instead of the number line that we're going off to the left or right, we will be shading an entire piece of graph, either on the above or below the line. So that's what we're going to work on this one. But again, we're going to let Desmos do a lot of the work for us. We're just going to answer the questions that's being asked of us. So the first thing says, given that y is greater than or equal to negative 2x plus 9, do these points satisfy this equation? Now, in order for a point like 7, 4 or negative 1, 3 and so on to satisfy the equation, that means if I were to plug this into this inequality, I get a true statement. Well, I don't want to do all that work this time. Again, because of the amount of time we have, we just want to know that, hey, if I graph this line, and we'll show you what this looks like, will it fall into the region or not? Will it fall into the shaded area or not? That's all we need to know. So we're going to plug over here, and hopefully I've gotten both of these things on the same screen, but we're going to plug that y equals in there. So we have y. Now I have to do the greater than or equal to, so I have to use my keypad down here and find that. So I need that guy right there. Negative 2x. See how it's making a shading? Plus 9. All right, so basically how this works, let me zoom out a little bit, is anything in this area makes the statement true. Anything out here makes the statement false. It's that easy. So all I have to do is plug in these different points and see if it falls in the white part or in the purple part. So over here on the next one, I'm going to type in 7, 4. Look, there's the point right there. Bam, it's in the region. So the answer to A is yes. Let me put in negative 1, 3. Now, if you don't want to put in the points, you don't have to. You can just look up the graph. But because I'm zoomed in so much, I don't know what I did there. I think that's a comma. Can't tell. Okay, yeah. So here's the point. Since I'm zoomed out, I should say, so much, you can't really see. But if I zoom in to and actually read negative 1, 3, I can see that it's in the white part. You can do it that way, or just type in the points or type in the points and see if it's in the purple part or not in the purple part. It's really that easy. So the next one is 10, comma, negative 5. And that's inside. So for our answers over here, this was a yes, this was a no, and this was a yes. And yes, it's that easy. All right, so the hard part on this, in this particular chapter section or lesson is going to be writing equations. So once you write the equations, then you can put them into Desmos, and then we can figure out the answers. All right, so remember that when Desmos graphs, it can only use x and y when it graphs. So we want to make sure that we're using x's and y's when we read this. The easiest way to do this is as you read, the first thing mentioned is usually the x, and the second thing mentioned is usually the y. All right, so we're going to read this. John's selling t-shirts. Plain t-shirts cost $8, so that's our rate for plain t-shirts. And the graphic t-shirts cost $7 each. So this is going to be, if we were to change this into plain t-shirts, this would be X, and the graphic t-shirts would be Y. And he wants to make at least $1,200. So back when I asked you how to write certain inequalities, at least, at most, and all that, this is where that comes into play. All right, so at least $1,200 means I want to be greater than or equal to $1,200. I want to make $1,200 or more. So this value wants to be 12 or greater than or equal to 1,200. So I want to make at least that. So I'm going to write an inequality, 5x. Okay, so here's our rate, $5 for every x, every plain shirt, plus $7 for every y shirt, has to be greater than or equal to 1,200. All right, so let's put that into Desmos and see what that looks like. So let me wipe this out. All right, 5x. See, and what's nice about Desmos is I don't have to put anything in any particular form. So that makes it easy. It'll graph in any form, so I don't have to put in y equals mx plus b if I don't want to. Now, if you notice, everything looks white because this number 1,200 is quite large, so I have to zoom out, and there's my area. Okay, so I want to know some of these. So I have some questions that are being asked of me, and I want to know. I want to see if I can figure out the answers based on what I have graphed here. All right, he sells 150 plain t-shirts and 60 graphic shirts. Will he be able to cover the product costs? So 150, okay, so here's his line right here. Anything over over the 1,200 over here and anything under $1,200 is going to be there. Okay, so basically he has to make at least 1,200, which means this dark red line right here. He has to make at least 1,200 or more. If he makes under 1,200, he's going to be in the white, which means he's going to be in trouble. That means he's not going to cover his product costs. So all I have to do here is type in, okay, remember that 150 is X and the 60 is Y. So all I have to do is put 150 comma 60 in there. And I can see, it looks like if I'm not sure, I can zoom in, look. It shows that it's below what I need. So the answer to this is no. He will not be able to meet his product costs because he's still in the unshaded area. All right, the last thing says he sells 90 graphic shirts and we want to know the minimum number of plain shirts he must sell to break even. Break even means this line right here. This is his break even line. Means if he goes below it, he's lost money. If he goes above it, he's making money. Right on this line means he's just made enough to cover everything. All right. So what they want to know is, okay, so I want to know if he sells 90 graphic shirts. Remember, graphic shirts is Y. So if Y is 90, so I don't want to use an ordered pair. I want to use an equation when Y is equal to 90. Okay, so Y equals 90. I can see where I hit the red line. If I hover over that, it says 114.90. That means I need 114 plain shirts just to break even. If I make more than 114, I will be in here. If I make under 114, I will lose money. So that's the minimum number of shirts is right there. That's what it is, break even point. Anything above that, notice anything in the red. If I click here, it's anything above. And of course, remember, it's not taking into account, it doesn't know you're doing actual shirts, so that's why it's giving you all these strange numbers, 145.4 and all that, because it doesn't know you're dealing with shirts. So you're going to have to keep that in mind when you're doing these. That you might have to, like if this is 113.9, you would have to say 114 shirts. Okay, so you have to round because remember, we're talking about whole shirts. But that's how you're going to do these. So I know when I get down below in this in your worksheet, in your notes, it gives you all of the ways of doing this graphically by hand. I already have them in y equals slope-intercept form, and you can do that. And what I would do is, it's going to take a lot of time to try to explain the shading. What I would do is just punch this into Desmos and shade accordingly. All right, so you might want to graph the way you know how to graph, which means this is your B, your start, or your begin, and this is how you travel. Okay, so this is how you move. All right, and to get to the next point, and then just graph the line. So I'm going to do that. So -1 is down here, put a point there, and I'm going to go up 2 and over 3. Now, on inequalities, I'll just tell you, if you're not using Desmos, you need to know this, that if you don't say equal to here, then you have to do what's equivalent to that open dot when we did it on the number line. So remember how our number lines used to be like, this would be like a 4. We'd have a number line here, and this would be open dot and then off to the right or something like that. The equivalent on the graph is going to be the dashed line. That's equivalent to the open dot. Okay. Now all you have to do is, again, you could put this in the Desmos if you want. You could also, if you notice it didn't go over 0, 0, you could test it. If I put 0, 0 in here, will it make it a true statement? And it looks like it doesn't. So if I put a 0 in here, this is -1. 0 is not less than -1. So since 0, 0 didn't work, you would shade over here. Okay, but again, if you didn't get what I just said, that's okay. Just make a dashed line. As soon as you put it in, I'll just show you. I could put it into Desmos. By the way, if you hit this little home button here, it'll default back to the smaller grid, since we were way out there. All right, and I'm going to put in this y is less than 2/3 x minus 1. Okay, which is exactly the graph that I have. Okay, so I'll shift it over, you can see both. Okay, so I typed it in, but again, the dashed line comes from the equal to. Do not make this solid on any of your stuff. If this is dashed, you better make yours dashed too, or you lose points, and make sure you're shaded correctly. All right, and so the rest of these are done the exact same way. You can put them into Desmos. You could also zoom in a little bit, and if you want to make it accurate, if you want to let Desmos do the work, that's fine, but make sure that you are actually plotting points. So like, see how 0, 1 I can read, and then I have to read something else that's easily readable, and it looks like, let's see, 3, 1, which is the other one I have. That's readable too. There it is, right. Ooh. So again, 3, 1. Now, to me, that's the graphing of the line is easier to do by hand than use Desmos, but you can do it if you want. To me, it's easier just to plot the line, go and put it in Desmos, look at how it's dashed and shaded, and go from there. But that's how you're going to do a lot of these other problems. I'm going to go and do some more of these word problems, and so we can get used to that. All right, so here we go. I'll do 7 and 8 with you, and then because the rest of these again is Desmos bound, you can do this with Desmos. So I'm going to leave that to you. All right, so I just want to practice with the word problems because that's usually our weakness. So I'm going to work on the first one. Stephanie spends 10 cents per text message sent and 25 cents per picture message sent on her cell phone. Her monthly budget in messaging is $30. Write a linear inequality, represent the situation, then graph it. All right, so we're spending, again, first thing listed usually the x. So text messages are going to be x in this problem, and y is going to be the picture messages. All right, so notice that this is in cents. So this is $0.1, this is 0.25. We can leave all that, which is nice. So we're going to put 0.10x plus 0.25y, and her budget for messaging is $30. So she wants to stay under $30. That's her budget, means she's allowed to spend $30 or less. So that's why I have the less than or equal to 30. So this is the hard part for you, is making sure that you get this written in the right inequality. Again, when you have a budget, that means you're supposed to go to that number and not anything higher than that. So that's why if you do, then you're out of budget. If you stay under it, then you are within your budget. Okay, so we're going to put this into Desmos. So over here, clear this out. I'm going to type in our equation. Less than or equal to is down there. All right, so can't see much anything here, so let me zoom out. There it is. Okay, so now remember we can't go into the negatives because we're talking about numbers of text messages and picture messages, so we're really bound by some other things as well, like we can't go into the positives, so we're really kind of looking at this triangle right here. We're not looking at all of this because, again, it doesn't know that you're talking about money and things. It's just graphing. So you have to be a little bit kind of smarter than the Desmos. So again, it's graphing exactly what you typed in here with no other limitations. If you wanted to put some more limits in there, you could. You could put in, you know, making sure that they're positive or equal to 0 answers if you want. You can do that. But I would just think about the fact that you can't go into negatives and just stay away from there. So you're kind of picturing this triangle here. All right, so what are 2 possible combinations of text and messages that she can send and stay within her budget? So these are pretty easy. You can read any points you want within this gray area. So there's a gazillion different answers. You could say this one, you could say, hey, I did 50 messages and 50 pictures. I did 100 text messages and 50 pictures. I did 150 text messages and 50 pictures. You could go and you could name, I mean, it's easier because it's zoomed out a little bit, but you could zoom in even more. If you wanted to be even more specific, you could say, hey, I want to do 40 messages and 30 picture messages. So there's a gazillion different answers. There's no, as long as you don't name any points out here, you're good to go. So as soon as you started, if you had said, hey, I want to send 50 text messages and 150 things, you would be wrong. So as long as you don't pick anything out here in this white area, you're good to go. And it says use your graph. So again, doing this graphing, you see how I have this as, let's see how many spaces do I have here. You could technically, this is an easy one to graph because you only have, you could just hit this point and that point. Notice I went up. You could even use this. What's great about Desmos is you can zoom in and not, and then, okay, so like this is going to take 1, 2, 3, 4, 5, 6 spaces. So I could just label it, label these 6 spaces, these 6 numbers, 7 numbers, and do the same thing here, and I would have a perfectly good graph. So just try to duplicate this graph the best you can on that one. For the sake of time, I'm going to skip that, but just make this, and again, you notice that it doesn't even go into the negatives. You notice this graphing paper doesn't talk about any negative stuff. This is all in it's called the first quadrant. We talked about that in an earlier lesson. All right, so again, you have gazillions of different answers for this, and I'm just going to decide on one. I'm going to say 100 texts and 100 picture messages. Okay, so that's just one answer, and then I could say, make another one. I could say 100 texts and 50 picture messages. And again, all I'll be checking to make sure when I check some of your answers on these kinds of things is if you didn't go into the white in this example. All right, so let's do the next one. Okay, Scott makes $12 per hour babysitting, $8 per hour working at the grocery store. He will need to make at least $600 to buy a new computer. All right, so first thing mentioned is babysitting, that's X. Second thing mentioned is the working at the grocery store, that's Y. So the rate is right there, and the rate for that guy is right there. So we're going to make $12 for every hour babysitting, plus $8 for every hour working at the grocery store. He has to make at least, so he wants to make $600 or more to buy a new computer. And then we can pick out different combinations again to afford that computer. So I'm going to go back up here, type in my equation that I came up with. 12x plus 8y is, go down here and click greater than or equal to 600. Okay, and so again, you got lots to choose from. Again, don't pick any negatives because we're talking x and y are hours. So don't pick anything. So let me zoom out a little bit. You don't want to pick anything down here. You don't want to pick anything over here because these are negatives. These are negatives. Only in here are both things positive. So just be careful. Nothing over here will work. Nothing over here will work because this is the negatives. Nothing down here will work. Just keep in mind that Desmos does not know what you're doing with this inequality. It just graphs it. It doesn't know that you're doing physical things. And again, you can't have negative hours. So stay out of here, stay out of there. You want to be in here. And as long as you name something within this little region, you'll be good to go. Okay? So, and then again, it's any combination. So I could say 200 hours babysitting and 100 hours working at, well, let's see. Yeah, 200. I can even go even smaller than that if I wanted to. I could go, hey, I'm going to work, I don't have to even be in big numbers. I can swing these down to much smaller numbers if I wanted to. So I could even go down to, yeah, I'll probably leave it tens. Okay, so again, since I have that many blanks, I might do this by 10. I might say, hey, I want to work 60 hours. Again, this is 60, 0 right here. So this would be 60 hours of babysitting and no hours working at the grocery store. I could pick this guy right here. Oh, actually, let me put in some points just so you can see what I'm talking about. Okay, that's that first point. And let me put down another one. 50. Okay, so let me put these 2 points down so you can see. All right, so 60, 0 means I worked 60 hours babysitting and no hours at the grocery store. This one says I worked 50 hours babysitting and 20 hours working at the grocery store. Again, those are both, if I want to even break even, I could just pick something on the line. I could say, hey, I'm going to work 50 hours here. I just want to work 50 hours and nothing at the grocery store. And I could do that if I wanted to. Okay? If I do that, then this comes out to be 600 bucks. So 50 times 12 is 600 bucks. Again, you could pick right on the line if you wanted to. Totally up to you. All right, so that's how this works, and I hope it all makes sense to you. Again, come see me if it doesn't.